Okay, at the start of this section on the remainder theorem, we are going to have to understand what factors are, and we are going to have to understand how to divide numbers. So let's get started. Let's talk about what factors are first. We're probably going to fill up this space and erase it multiple times. So factors. So if we think of a number, we can think of a number like 15. 15 is equal to 3 times 5. That means that 3 and 5 are both considered factors, because when we multiply them together, we get 15. Now, we can think of this also with polynomials. We've dealt with quadratics in the past, and here's a quadratic that you would know, x squared plus 4x plus 3. This is just a number. Now, it's a different number for every value of x, but it is just a number. And we can write this as a multiplication question. If you remember sum and product factoring, it's going to be x plus 3 times x plus 1. This and this, these are factors. So in this section, we are concerned about determining the factors of polynomial functions. We've already looked at how to find the factors of degree 2 or quadratic polynomials. All right, so now what we're going to do is we're going to take a look at division and how that relates to factors. So I'm going to take a question. I'm going to write down, is 6 a factor of 735? Well, in order to determine if 6 is a factor of 735, we have to think, does 6 times something else equal 735? And that something else has to be a whole number or integer, no decimals allowed. So we can check this by dividing. Let's divide to check. All right, so we take 735, and we put it in the division algorithm. We put a 6 in front, and we start. 6 times 7 is, how many times does 6 go into 7? 1 time. 1 times 6 is 6. Subtract, it's 1. Bring down the 3. All right, 6 into 13, that's twice. And that's 12, and that's subtract, and that's 1. Bring down the 5. Does 6 go into 15? Well, it does twice, and that's 12, and that's 3. So we have a remainder of 3. Now, because there is a remainder, 6 is not a factor of 735. So we say 6 is not a factor of 735. There's a remainder. All right, now I would write this, if we go back up here, we saw how we had 15 is equal to 3 times 5. Well, in this case, I would write down 735 is equal to 6 times 122 and 3/6, or 122 and a half, or 122.5. All right, so here's our 122, here's our 3, and here is where the 6 comes from. So again, this is important. 6 is not a factor of 735 because there is a remainder. Well, now let's take a look at this. We're going to use this guy here. No, let's not. Let's come up with a new one. And we're going to ask a very similar question. So here's a polynomial. It is a degree 3 polynomial, x cubed plus 6x squared plus 11x plus 6. This is a cubic polynomial. The degree is 3. Our leading coefficient is plus 1. And our y-intercept is going to be plus 6. So this one's going to look something like, I don't know, maybe like this, right? That's going to be plus 6. It's going to go from low to high. That's because it's an odd degree. It can have up to 3 x-intercepts. I'm going to ask, is x minus 1 a factor of this? Is x minus 1 a factor of this? Well, let's take a look, and we are going to divide. Now, this will be your first time ever dividing with polynomials. So, we are going to set up a division algorithm very much like this one. So remember, we said down here, is 6 a factor of 735? So 6 went out here, 735 went down here. The same thing is going to happen in this case. We're going to take our x minus 1, put it out here, x minus 1. And it's going to go into our cubic function, x cubed plus 6x squared plus 11x plus 6. And now we are going to divide. So all we ever look at is this first guy. We just worry about the x. And then we're worried about this x cubed. How many times, so what do I multiply x by to get it to x cubed? Just like here, I did, what does 6 multiply by to get close to 7? And we chose 1. So what do I multiply x by to get to x cubed? Well, x times x, no, I don't want to put an x in, x times x squared equals x cubed. So I'm going to put an x squared up on top. I'm going to throw up an x squared. Then I take this x squared and I multiply it by x, and I get x cubed. Then I take this x squared and I multiply by negative 1, and I get x cubed, I get negative 1x squared. So does everybody see how I did that? I took this x, multiplied it by this to get this guy here. Then I took this guy, multiplied it by this to get this guy here. Now, if we look over down here, then we subtracted. Well, we do the same thing. We subtract. X cubed, take away x cubed is nothing. That's done. Plus 6x squared, subtract minus 1x squared is equal to plus 7x squared. Remember, plus 6 minus minus 1 is equal to plus 6 plus 1. Then we're going to bring down my plus 11x. All right, now we look at this guy, 7x squared and x. We think x times what gets me 7x squared? X times 7x is equal to 7x squared. So we write down plus 7x. So then we multiply it out. 7x times x is 7x squared. 7x times minus 1 is minus 7x. Write it down. We subtract. 11x minus 7x is plus 18x. Then we bring down the 6. And we repeat this process. This times this has to equal that. So this is going to be plus 18 Then we're going to get plus 18x minus 18 is equal to 6. And we are going, when we subtract, the 18x and the 18x are going to cancel out. Negative 6 subtract negative 18 is plus 24. So we get a remainder of 24. Now, there's a remainder here. So our answer to this question is x minus 1 a factor. Is x minus 1 a factor of this? No. There is a remainder. Now, if we look at this and how it's related to this, we can say that x cubed plus 6x squared plus 11x plus 6 is equal to x minus 1 times x squared plus 7x plus 18 plus 24 over x minus 1. All right, so this is our quotient. 6 goes here, so x minus 1 goes here. This answer goes here, so this answer goes here. And then our remainder gets put over our quotient. Our remainder gets put over our quotient like that. All right, so this we call just long division. Now, there's a quicker way to do this, and we're going to use the exact same question to figure out something called synthetic division. This is going to be called synthetic division. You need to know both. So in synthetic division, we set up a chart like this to divide. We are going to do the question, we're going to do the exact same question, x cubed plus 6x squared plus 11x plus 6 divided by x minus 1. This is the question that we did right here. We saw that we got a remainder of 24, so in this system we should get a remainder of 24. So here's what we do. We take our minus 1, we put a minus 1 right here. We're going to put a subtraction sign here. Then we take the coefficients. The coefficients are 1, 6, 11, plus 6, plus 6, and we write them out right here. So plus 1, plus 6, plus 11, plus 6. Now this becomes very algorithmic. We just go to the answer. The first thing that we're going to do is we're going to drop down this plus 1. Plus 1. Then we're going to take negative 1, plus 1, and multiply them together and put it right here. So negative 1 times plus 1 is negative 1. Then we're going to do plus 6 subtract minus 1. Plus 6 subtract minus 1 is plus 7. Do you see where this comes from over here in the long division? Plus 6 subtract minus 1. Plus 6 subtract minus 1. Then we do negative 1 times plus 7, and we put the answer here. That is going to be minus 7. Then we do minus 11, take away minus 7. That is going to give us plus 18. Notice, this is right there. Then we take our minus 1, times it to our plus 18, and write the answer right there. We're going to get minus 18. Then we do minus 6, or plus 6 minus 18, and we're going to get plus 24. This is our remainder. Now, this synthetic division is much easier to do. Now, what this means is this is our polynomial as an answer, and this will be 1 degree less than this. So this was our coefficient for x cubed. So this is going to be our coefficient for x to the power of 2. So it's going to be x squared plus 7x plus 18 with the remainder of 24. Notice that that is the same answer that we got right here. So our answer is x minus 1 a factor of this? The answer to that is no, according to division. All right, now let's talk briefly about the remainder theorem. So I just have to go and check something out really quick here. Just a second. Okay, so here we go. The remainder theorem. Here's what it is about. We have our polynomial based on x is equal to x cubed. We're going to use the same one, x cubed plus 6x squared plus 11x plus 6. So this is our polynomial. The question we're going to be asking, what will the remainder be if I divide it by x minus 1? What we've seen up here, we can do long division to divide it out. We can do synthetic division to figure it out. If our remainder happens to be 0, so we'll look at this one. If our remainder was 0, then this would be a factor. Since our remainder was 24, this is not a factor. How can we figure this out? Well, the remainder theorem states that the remainder will be the polynomial evaluated at the opposite sign. So I take this minus 1 and I change it to a plus 1, and I evaluate this polynomial at plus 1. So we'll just see how that looks. If our polynomial is x cubed plus 6x squared plus 11x plus 6, then the remainder, when we divide it by x minus 1, we evaluate the polynomial at plus 1. So it's equal to plus 1 cubed plus 6 times plus 1 squared plus 11 times plus 1 plus 6. So plus 1 cubed is just plus 1. Plus 1 squared times 6 is plus 6. Plus 11 times plus 1 is just plus 11 plus 6. This is equal to 7, 18, 24 is equal to plus 24. So then our question is, Is x minus 1 a factor of this polynomial? The answer is no, because the remainder when we divide it is not 0. So that's what the remainder theorem says. All right, so that is how long division, how we do long division with polynomials, how we do synthetic division with polynomials, and how we can determine the remainder of a division question using the remainder theorem. So what will the remainder be if I divide this polynomial by x minus 1? Well, I evaluate the polynomial at plus 1. Now, all of this really only works for factors where the coefficient of x is equal to 1, and that's what we'll limit it to in this case. All right, so you should have an idea of what long division is, synthetic division is, and the remainder theorem. In the examples, we will apply this.